Good afternoon, parents. Welcome again to Parent University. This is the beginning of the math session for 5th grade. My name is Phyllis Collins. I am the math coach for Florence Howard Elementary School.
Hello, and my name is Dara Moss Knight, and I am the math coach at Collins Roads Elementary.
Hello, my name is Felicia Douglas, and I am the math coach at Dodge Elementary School.
Good afternoon, Nicole Lund, Meadow Lake Elementary math coach.
Hello,
We would just make sure y'all was awake.
my name is Jasmine Stevens. I'm the math coach at Craighead Elementary.
Hi, Christy Eller, math coach at Ingrid Davis.
Okay, welcome again, parents. We want to thank you for coming today. We hope you will learn valuable information regarding your child's 5th grade year. We hope the information shared today will help your child have a successful 24-25 school year. Every Alabama child needs foundational skills to be successful in career and life. The 2022 Alabama Numeracy Act is the state's comprehensive plan to improve math instruction for all students and teachers. The Alabama Numeracy Act has been established to implement steps to improve the mathematics proficiency of public school K through 5 grade students and to ensure that those students are proficient in math at or above level by the end of the 5th grade year by monitoring the progress of each student from one grade level to another. First quarter math standards, the concepts. Patterns and powers of 10. Multiplication of whole numbers. Volume, cubic units. Volume, formula, compound figures. Division of whole numbers. Fractions as division. And numerical expressions. And as you see, some of the standards have asterisks in front of them. These are called critical standards or concepts. You might ask, well, what is a critical standard? Aren't all standards important? Critical standards are the major focus areas in each grade level. Standards in which a student must demonstrate mastery to be successful in the next grade or course. 65 to 85% of the year's instructional time should be spent on those topics. What about the other standards? Although not all standards are considered critical, all standards should be included in instruction. Other standards often support specific critical standards and will need to be mastered as part of the work on those standards. The district puts out a pacing guide with all the standards for all year, and they're separated by quarters. And the pacing guide tells the teachers what to teach and when to teach it. Today we're going to focus on mathematics standard number 7, and it is find whole number quotients of whole numbers with up to 4-digit dividends and 2-digit divisors using strategies based on place value, the properties of operations, and or the relationship between multiplication and division. Illustrate and explain the calculation using equations, rectangular arrays, and or area models. That's a whole lot in one standard, as you can see. Will we teach that all in one day? No, we're gonna break it up. Every day, we'll teach something a little bit different. We start off with the foundation skills, and then we add on and build up until they can master that standard.
Okay, so when we're looking at the math standards, typically parents did not learn the standard the way that their students are learning the standards. And the whole way that we're teaching math now is for students to understand what they're doing, not just to find the answer, but to understand the process and the reasoning behind it. So this standard that we're looking at is a division standard, but we have to build it from the ground up. So the standard says that the students need to be able to divide up to a 4-digit by a 2-digit. But because we're not just gonna throw them out there with large numbers, we're gonna start with smaller magnitudes of numbers so that they can get comfortable with what they're doing and build up to a 4-digit number. So this problem is a Spark Your Learning problem, which is basically to get the students thinking about the math and what they're going to be doing as a whole. So every math lesson should have some type of collaborative learning component where they work with a peer or a group. So we're gonna put on a student hat and we're gonna look at this problem, which we're gonna be representing division with 2-digit divisors. So it says you are a game designer designing a treasure hunt game. The game board is a grid with a treasure chest behind one of the squares. The rectangular grid has 96 squares. If the length of the grid is greater than 10 squares, how wide can the grid be? So I want you to turn and talk to your shoulder partner and think about how wide could the grid be if you know you have a total of 96 squares. So keep in mind the total and that your length has to be greater than 10. So I'm gonna give you a couple of minutes to think about that and talk to your shoulder partner. Don't be shy. It's a rectangular grid, and the length is greater than 10, and the total is 96. We're trying to find the other dimension, which is the width. Now, this is 5th grade, so students should have the background knowledge of area, which is length times width. That's a 3rd grade prerequisite skill. So we know that the length times the width is going to equal the 96. Then now we're just thinking about what could that other dimension be. One has to be greater than 10. What's the next one? And it has to be equal to 96. Does anybody want to share their thinking? It's pencils on the table. You can use the back as a blank sheet. You also have grid paper. Does anybody want to share their thinking? Don't be shy. You want to share their thinking? Okay, come on, read it. Show us what you can.
So we were looking at the total had to be 96, and one of the lengths has to be greater than 10. So I'm thinking about my basic facts, and I know that 12 is greater than 10, so I know that 12 times 8 is 96, and length times width is 12 times 8, so that would be my 96.
Okay. What do you guys think about that? Hold on, we're going to let them get us back started. So she said she used her background knowledge, and she said that she knew that 12 was a factor of 96. And it met the requirement, you can leave it right there, it met the requirement of being greater than 10. So she used 12 as one factor, and she knew that 12 times 8 was 96. So that gave her the answer of 8 as the width. And so if you look up here, here's a possible solution. It says 96 squares divided by a length greater than 10 is going to give me the width. We want to make sure that when we teach in division, we want to relate it to multiplication, because division is the inverse, the opposite operation. So you can use multiplication to solve division. You can use addition to solve subtraction. So in this case, they should know that the width is times something greater than 10 is going to be 96. You had to think about what number greater than 10 was a factor of 96. 96 divided by 12 is the width. The width times 12 equals 96. And if you look at the bottom, you see an equal groups model of 8 groups of 12.
So that long rod is a group of 10.
So If you're not familiar with base 10 blocks, which as a 5th grade student, these students would have had a lot of work with base 10 starting from 2nd grade. So the rod or the line is 10, and each square is 1. So we see equal groups of 12. And so students could have drawn a model, they could have worked with base 10 blocks to get to the answer. If they did not know their factors, they still could have solved the problem by using physical manipulatives. So this would be a type of Spark Your Learning introduction problem for them. You can go ahead. Okay, so here's the standard. And keep in mind, we're not gonna jump to 4-digit by 2-digit. We're gonna work our way up. So if you notice now, we have a number that has a greater magnitude. So here's our standard. I can find the quotient of numbers up to 4-digit divided by 2-digit divisors using visual models. Emphasis on the visual models. So you have 2 options here. You can scan the QR code and it's going to give you some virtual base 10 blocks that you can drag and drop. Or you can use your grid paper that's on your table that looks like this. And we want to see if you can visually represent 187 divided by 11. And I want you to keep in mind that we are going to relate division to multiplication. So we know that our total is 187, and we know that we have 11 groups of something. So the inverse will be 11 times something is going to give me 187. So go ahead and see if you can come up with a visual model to represent 187 divided by 11, and 11 groups of something is equal to 187.
And parents know that long division, our long division way is not introduced until 6th grade.
Visual model.
Visual model.
You know you want to go to that traditional algorithm, but that is a 6th grade objective.
Yes.
Not
So,
appropriate for a 5th
The
grade.
standard long division is not learned by students until 6th grade. Everything up until this point is visual models. So here's a hint. We know that area is length times width. We also know that we need a rectangular shape. So we know one of our dimensions, so start your model with 11 as one of the sides. Couple more minutes.
Draw your rectangle. And one side is going to be 11.
Work with your table.
Rita, y'all gave up on me?
Do y'all need some graph paper?
They have some, they gave up on me. What happened to that motivation?
I can shoot it, I'm doing it in my head.
They do something. Like, well, take one, see, okay, put it on paper. Oh, you
So don't fret, we're gonna look at it. I just want y'all to try. Yes, that's the answer. Can you visually represent? But can you visually represent?
So your students might be given that if the answer choice might be it might be a model, and they have to choose the model that corresponds to this equation. Because if we go back to the standard, it said using visual model. West, and this is a standard area, they have to be able to
So, I had a couple of people say the answer. Yes, the answer is 17, but was that what was asked? What was asked was show it using a visual model. So, in often cases, you may tell the students the answer. I may say 187 divided by 11 is 17. So I want you to prove it because I want to see a visual model. Do we have anybody with a representation of 187 divided by 11? Do we have something?
Review that. 187 divided by 17. And you take it down.
Okay, so winner, chicken dinner. Can you share for me?
Okay. Everybody know division, so you know 187 divided by 11 is 17. So if you use me a visual, you take it across 11 times and 17 times down, and it makes a rectangle.
Of 187. Okay, so if you look up here, if you scan the QR code, it will take you to virtual manipulatives that look like this. And it walks you through the steps and it asks you to create a rectangle of 187 squares. So, we know that with our background knowledge, we know that multiplication is all about equal groups. So when I create this model, I know that I can't have 11 over here, 14 over here, 10 over here, because I have that background knowledge of multiplication being equal groups. So when I create my model, I'm going to start with 11 because that was the factor that was given to me. And I'm going to keep doing that until I have 187. And then once you've done that, you will clearly see that you have 17 groups of 11 or 11 groups of 17. Because in 5th grade, until we put the problem in context, it doesn't matter if we have 11 groups of 17 or 17 groups of 11. It's when we put that problem in context, that's when it matters. So this is what that visual would look like. And if you notice where it says division problem, you see the traditional way that we're used to seeing division. But that does not mean solve it using long division. Because if you notice, we have 187. If we look at the model in groups of 100, 10s, and 1s, the first thing that was subtracted was 10 groups of 11, which was 110. Then I had 77 remaining, so then I took out 7 groups of 11. So even though it looks like the traditional algorithm, it's not. It's partial quotient because we're breaking it into groups. Any questions about this so far? Now, does this come the first time you do it? Absolutely not. This is something that the students are going to have to practice over and over and over. So, in the classroom setting, we will have physical base 10 manipulatives, and we will do that for a while. Then we will move to virtual manipulatives and drawings of the manipulatives. Then we will move on to partial quotient, where you see it as a division problem. It's a process. Okay, so here's another simple problem. We're not going to work this problem, we're just going to talk about it. So, y'all got scared. So, we use the grid paper. So the progression in the classroom will be physical base 10 blocks. Then we move to grid paper where they can see each individual square. Then the next progression step would be what's called the open area model. And the open area model simply is the grid, the rectangular grid without the individual spaces inside the shape. So once I've done this so much, I don't need to see the individual squares inside of the boxes. Now I know that 10 groups of 24 is 240. So if you look over here, I started with 888. I know that I'm putting it in groups of 24. So if I take out 10 groups of 24, that's 240. I subtract 888 minus 240. That gives me 648 left to divide. Now, since I'm comfortable with tens, tens is a friendly number. Most students are going to be comfortable with tens, hundreds, and thousands. So if they need to use that, let them. So now I'm going to take out another group of 10, which is another 240. So 648 minus 240. Now I have 408. I have taken out 2 groups of 10. And now, can I take out another 240? Yes. 408 minus 240. Now I have 168 left to divide. So I have taken out 3 groups of 10. So I know that my answer is greater than 30. So if this was a multiple choice test, I know that anything under 30 is not going to be the answer because I have already taken out 3 groups of 10. So now I have 168 remaining to divide. 10 groups is too much. So now I'm going to think about what's another friendly number that I can use. It could be 5, it could be whatever your brain or the student brain takes them to. So I know that half of 240 is 120. I know that I have 168, so I can easily take away half of that and subtract 120. So now I have taken out 5 groups of 24, which is subtracting 120, and I have 48 remaining. Now, 2s is also a friendly number. As a 5th grader, 2, 5, and 10 are going to be the most comfortable numbers for students to work with because it's going to be what they had the most work with. So I know that 2 groups of 24 is 48. That's exactly what I have left. So I can take that out and I have 0 remaining. In order to find my complete answer, my total quotient, I have to add all of my partial quotients up. So I took out a group of 10, another group of 10, another group of 10, 30, a group of 5, and a group of 2. So my answer, my quotient is 37. Does that make sense? It's a process. So this is transitioning from grid paper to open area model. So this is why this is a critical standard. This is not going to be mastered in 2 weeks. Critical standards need to be taught from the beginning of the year and practice to the end of the year. Because as you see, it's not going to be easy for students. They have to have a lot of background knowledge and it builds. So they have to practice it all year. So, just moving on in the progression, once I have had enough experience with grid paper and open area model using tens and friendly numbers, then students should be getting comfortable with taking out larger groups. So now we're at the end of the standard of 4-digit divided by 2-digit. We know that if I have 3,180 of something, it's not going to be efficient for me to take out groups of 10. I'm going to be there all day. It may not even be efficient to take out groups of 50. So if you look now, 15 times 200 is 3,000. That's very close to my answer. So now I'm going to start with taking out a group of 200 15s, and then a group of 10 15s, which will be 150, then a group of 3 15s, which will be 30. 200 is still an easy number to work with because students should have a background knowledge of 15 times 2 being 30, And so they can easily translate that knowledge to 15 times 200, which is 3,000. And if you look over to the side, it's set up like standard algorithm, but it's still partial quotient because they're subtracting the number of groups. I subtracted 200 groups of 15, which was 3,000. So now I have 180. I subtracted 10 groups of 15, so now I'm subtracting 150. Then I'm subtracting 3 groups, which I see an error in this problem. I didn't make this problem, but I do see a mistake. But do y'all see the mistake? So that's what I tell my students all the time. I don't write the books.
Amen.
I just teach the curriculum and the standards. But this will be a great teaching moment for students to find a mistake, because I've looked at this 100 times, and this is my first time seeing a mistake. Does anybody see it?
I see it. I just saw it.
So how many groups of 15 is in 30? 2. What does it say up here? 3. So that should be 212. So that's a teachable moment. But if students are working through it, then they will definitely correct you when you're wrong. And that's what I always tell them. We're all learning together. No one person has the right strategy all the time. Teachers make mistakes. Obviously, book companies and people writing problems make mistakes too. Moving on. Okay, so that was a quick overview or run through of Standard 7. The main takeaway is students need to have the opportunity to put their hands on concrete items to solve problems, and then they need to go through that concrete, that pictorial, drawing what they building it, drawing it, and then the abstract, which will be just numbers. If you jump to the just numbers too soon, then students don't understand the why and they often make mistakes. So here are some things that will support this standard. Base 10 blocks, which is the concrete I just told you about. Grid paper, which will be the pictorial version of base 10 blocks. Making sure that the problems have a real world context. Because anytime we do math, it's going to have some type of context behind it. We just don't walk out in the world and say, okay, let me multiply, let me divide 3,198 divided by 35, just because I want to do some math today. So it needs to be in real world context, and then we have the abstract, which is solving the problem without concrete manipulatives, without grid paper, but having that understanding of all of those things, but now can solve it with just numbers.
Okay, she talked about the importance of concrete and representational experiences. Concrete objects are tangible, they're visible, they're touchable. Using physical objects or manipulatives, such as counters, blocks, pasta, coins, beans, whatever you have at home that children can manipulate and move. This helps students understand the concept of division in a tangible way. Okay, she talked about representational, using drawings to solve problems. Using graph paper or drawing arrays and area models reinforces the concept visually. Here's how you can help at home. Use household items such as pasta, coins, buttons to create division problems. Draw arrays and area models together on paper. Practice online using virtual manipulatives to solve problems interactively. And these are your online resources.
So if you want to take a couple of seconds, if you have the phone, and scan them and save them. So the first one is DotX, which is a type of virtual manipulative. The second one is another version. These are a little more lower level friendly as well, but it builds up. So that's Toy Theater. And then the last one is Math Learning Center. If you do not have a device to scan, then the websites are up here. I will leave it up here for you to write them down, or you can take a picture of this slide.
And these sites are all free,
Yeah, all
free for
free.
you to use, you and your children.
We know that we live in a world of technology, so
Right.
anytime that we can bring that into it, the kids are more apt to stay engaged. And so all of these also pair well with whatever homework assignments may be coming home, because it's not problem specific. So whatever they're having to do, you can easily pull up any of these websites and utilize those manipulatives to solve whatever problem they're given by their teacher.
Okay, so the key takeaways from this session: understanding place value concepts supports division understanding. Remember, using multiplication directly helps with division. The use of multiplication directly assists in any division problem. Representing division with arrays and area models is essential. Use concrete and representational experiences to solidify understanding.
So, two of the things that you have, one being the family guide, is the book here. And it is all K through 8. So if you flip to 5th grade, it gives you some things, some suggestions for at home. It talks about the importance of the standards. It talks about multiplication, division, fractions, and volume as content priorities. Meaning, yes, the other standards are important, but these are the things that your students need to master in order to be successful in the next grade level. And then on the back, it also gives you some homework help. It gives you the website amsci.org. It gives you Khan Academy, Math Help, Wolfram Alpha, and PBS Learning Media, which are all homework help websites. And then it also gives you the QR code to AmSci, which, if you're not familiar, is Alabama Math, Science, and Technology Initiative, and it is what the state uses to help students learn math by doing, and so that they'll be ready for those STEM jobs, which is the way of the world now: science, technology, and engineering and math jobs, college and career ready jobs. And so then the other thing that I wanted to talk about is this packet, which basically gives you an overview of the curriculum that Mobile County uses and shows you what each module should look like. So that's also in your bag. And then the books that they talked about earlier are also an option, but I just want to remind you that in 5th grade, they're learning division through models. So when you get to the division page, you will see it set up as a traditional standard algorithm division problem, but that does not mean you need to solve it using standard algorithm. It just means it's a division problem. Yes, it has a Spanish page. It should have an English page and a Spanish page. So if you don't speak Spanish, then disregard. But right here on page 14 in the Conquering 5th grade, I see that all of these problems are set up in the traditional standard algorithm way. That does not mean I have to solve it using long division. It just means I need to recognize that this is a division problem. So this is where you can pull out those virtual manipulatives or that grid paper and say, okay, let's model this problem. Any questions? So if you do not have a math coach in your school, within the next 2 or 3 years, every school in the state of Alabama will have a math coach. So if you do not have one, then you will be getting one. But there is a great likelihood that your school has one. So if you have questions or need more resources, then feel free to reach out to your school.